And record too. So this is probably a great lesson whenever we're kind of towards the end of class here on a Monday morning, because it's a really easy lesson. I think students have a pretty easy time with this. Square roots and cube roots are really easy to graph. And we've been talking a lot about inverses, and whenever I introduced inverses, I showed you a graph of a parabola, and then we rotated it around to look at what the inverse looks like. Well, the inverse, if you think about it, if a parabola or a quadratic, if you think about that one we graphed was x squared, what's the inverse operation of squared? Square root. So when we graph it, what happens is, if this is the parabola, then the inverse of it is on its side, but we don't include, it actually has a bottom half here that we don't include. Why would we not include that?
It's not real numbers.
No, that's right. They wouldn't be real numbers. I'd end up with imaginaries under the radical if I included that part, and I don't graph imaginary numbers. So I only include this top half. So therefore the graph of a square root looks just like this. Okay, it's just the top half of the parabola on its side. Now, again, because that A in front could make it go up or down, it could look like this, or it could look like this.
It couldn't go left.
No, it won't go left. Again, with those negative numbers. And plus, if you think about the parabola, if we just took the parabola and did the inverse of it, that's what it's going to look like. We use 2 points to graph square roots. Of course, we're talking about square roots first. I should probably tell you that. Square roots. We use 2 points to graph them. If you have the point where it starts, I call that a starting point. And then you need one other point to kind of find the direction in which it goes. I call that a direction point. This is not by any means in your book or anything like that. This is just what I call it. I say you need 2 points, you need a starting point, you need a direction point, and if you can find those 2 points, you can graph the square root. Okay?
We will have to find the endpoint. With that.
The what?
There will be no endpoint, right?
What you mean endpoint? You'll have to find the start point and the direction point. That's it. But it's really, really, really easy, because with the square root graph, you know, with the quadratic graph, I have ax squared plus bx plus c, right? The square root graph looks like this. I see some very similar variables in here, right? Exactly. It's like vertex form of the, and it's still doing the exact same thing. And if you can relate it back to that, it makes graphing a breeze. A still shrinks, stretches up, down. And HK is still my vertex, or my, in this case, my starting point. But it's essentially the vertex of the parabola. It's the same point. Does that make sense to you so far? So that would be my starting point. So that only leaves me finding a direction point. Remember,
Wait, how do you know where on it the direction point is?
we're going to move to the right of the starting point. So let me show you an example, start to finish, and it'll make a little more sense. Let's say I asked you to graph. Let's do 2 times the square root of x plus 1 minus 3. Okay, this one has all the variables. It has the a, the h, and the k. By the way, if a is missing, what is it? 1. If h or k are missing, what are they? 0. Okay. So for this one, what would my starting point be? Or the vertex point? -1, -3. Remember, we have to change that sign, right? All right, so let me get an axis on here. -1, 1, 2, and 3. Now I need an easy point or a direction point. I'm going to go ahead and label that with an S for a starting point, because I don't want to get the 2 points mixed up and have my square root graph going off in the wrong direction. So for my easy point or my direction point, you want to stay right beside your starting point, just like the parabola. It's just like when we were graphing those. So I would do 0. This will be my direction. Again, these are not mathematical terms, start and direction. This is just because it makes sense to me. So when you plug that in, what do you get? What? Y'all plugged in 0? So 2 times 1 is 2, and 2 minus 3 is... If you always stay 1 over from your starting point, you'll always end up with a 1 under the radical, which is going to make life really easy. So 0, negative 1. That's not hard, right? Hardest part of this is going to be what I'm fixing to ask you to do. Domain. What's the domain? So domain is my x. It's left to right. What is the domain? Joseph, what would the domain of this be?
It would be negative infinity. Wait, no, that's the range, right?
No. My domain and range are restricted on this one, if you look. It is. It's negative 1 to infinity. I'm going to have a bracket here because there's actually a point. So left to right, the furthest left it goes is negative 1, and then it goes forever right. Now looking at the range from bottom up. Negative 3 up to infinity. These 2 points are always going to be that starting point. Okay? It's pretty easy. Yes, for these.
Because it's always plenty.
Square root. We're doing cube roots too, but yeah. Let's do one more. So Jeremy doesn't say that the homework looked worse than the classwork.
No, it's still bound to happen that we don't understand.
I mean, like, I can understand it in class, and I get the homework, that's a graph.
Well, you know why that is? All right, this is one for you to try then.
Now, but I'm going to forget.
You don't try.
This is another.
That's not the 5th root. That's 5 times the square root of x. There you go, graph it.
Sorry. Yo, what?
Straight from the book.
So with the start piece.
I'm sorry, the zeros in that piece. I'm about to say.
That's right. This one's easier than the one. See, that's straight after homework. It's easier than the one that we did together. You start at 0s because the H and K are missing.
Oh, you say words?
I didn't say that. You want me to say word?
Start saying words.
It's not quite my style, Corbin.
What do you say?
Yeah, yippee. I don't know. What do I say? I don't know.
She says I don't know. Hundo P.
No, okay.
Don't look until you have yours.
I didn't know if you had
Bro, I'm gonna assume, and if I assume right, it's just.
That's a horrible.
Yeah, I think it's right. I did it.
You go 1 over. Can it look like?
What?
So we'll always have like a ray.
Yes.
I'm not even gonna lie.
it looks fun.
No, I knew what I did. It's kind of like, but I did it.
Looks like
Yeah.
If you label your start point with an S, you'll always know this is where I start with my pencil and I go towards the other point.
I like big time rush. I think I said my mom.
Uno mas with the square root.
Wait.
I'm gonna really try to stump you with this one.
Yeah, please do.
It's not happening. Who's challenged that? Don't say it when you get it.
I'm part of the rebellion. I'm trying to do.
Four on the frame, you know? What are you doing? I give up.
Wouldn't it just
See, that's just, that's easy. Hey, what's that formula, the HK thing?
I'm going 8-1, probably wrong.
Does the one over 2 matter? So it's like the.
It does matter.
And when there's nothing for H and K,
Some of you have figured out the trick already.
Why you don't freaking know?
yeah, and then
Exponent of 1/2 is the exact same thing as a square root.
yeah.
So if you go back to the first section where we were changing forms, it's the square root, and now it becomes easy. This one is also different because I did give you one that flips upside down. It's the bottom half of the parabola instead of the top half of the parabola.
And the demand and range is going to be different. So it should be 8.
I'm at 9.
-1, there's a negative in front of that radical though.
That's right.
Oh, it's
So if I grab that,
after we got
I'm
those.
on point though.
Easy.
Shut up.
Yep.
Shut up. That's like,
It's because you're in your bag.
you need a love slap.
Think about it being the bottom half there of a parabola. Think about the way parabolas look. Think about your vertex and think about your easy point because you've got half of a parabola on its side is what you've got. How about the domain?
So you always see the radical.
Domain
Yes,
is
Palmer.
-1.
How about range?
The range, though, is 7. Right? Or-
Is it?
Hold on.
Ooh.
It's domain. It's -1.
It's a range.
What, the range is what we're looking at.
The range is infinity.
Is what?
It's infinity. It's going.
Yeah, it's definitely bounded.
It's
Anyway, total cost.
So it can be, oh, switch that around.
That's what I said.
No. You said 8 to infinity, and then you said infinity to 8.
It's a negative.
It's negative infinity. You have to think about what it means because it's opening down. It can be small, but it stops at 8.
The recording cost.
Let's look for a minute then at cube roots. So when we talk about graphing a cube root, what is the inverse operation of a cube root? To the third power, right? So if I think about the graph of a third power, that's a cubic. So it looks something like this, right? And the humps could be a little more defined if we needed to. Or it could be this way, depending on if that A was positive or negative. So if I think about what inverse means, and I'm switching X and Y, then a cubed root, so these are cubics. Whoa, if I can spell cubic. Cubic. So a cube root is just going to be on its side. It's going to look very similar. So I'm going to look something like this.
So it's going to look like a hurricane symbol.
Is that what a hurricane symbol looks like?
I mean, sort of like, you ever like
Or
on the
this.
beach you see them, it's like,
No, but those are in like circles.
Okay.
yeah, but that's
So now what I'm going to have, this is going to be my start point. I'm going to have 2 direction points because I need to go off in either direction. So now instead of just adding 1, I'm going to add 1, find that point, and then I'm going to also subtract 1 and find that point. I want to get on either side of that start point to find the way it goes. Other than that, it's exactly the same as graphing the square root. Nice thing about this is the domain and range on these are not restricted, which means what? Negative, infinity, infinity, every which way you look. Okay. So that's easier. All right, the equation looks like this. Oh my, it looks so similar because it is. It's just a cube root instead of a square root. Now I can have a negative under there, and that's why I need to go off in both directions. Okay? Let's do one. Y'all ready, Freddies? I've been trying to do examples from your homework or very similar to your homework. I'm looking at your homework as I come up with examples, so y'all don't whine.
The K is not under the radical. Not amplified.
Yes.
No.
Like correct.
Okay.
Like,
The H is under the radical, the K is outside the radical.
got it, it makes more sense.
All right, let's say I have the equation y equals 2 times the cubed root of x minus 4. And I want to graph. I'm missing something here, but that's okay. What's my start point?
4, 0.
Good job. I go ahead and put this on here so I know. All right, I need to go in both directions. So I need 2 direction points.
5 and 3.
5.
Wait, no, you use 4, 0, not 0, 4.
Ah, thank you.
This is smaller now. Got that recording?
It got you correcting me.
4 plus sucks.
Oh my goodness. Okay, 4, 0. Golly, I am dyslexic this morning. All right, and then, so 5, and then we said 3. Everyone sees why we use those 2 values? No?
Is it close?
You added 1 and you subtracted 1 from where you started, to the right and to the left. So when I plug these in, I get 2 times the cubed root of 5 minus 4, which is 5 minus 4 is 1. The cube root of 1 is 1, so I just get 2. So 5, 2, double small like 5, 1. And go the other way. And this time, whereas before, you were always getting 1 under the radical, now you'll always get 1 and negative 1 under the radical. Negative 2, that's right.
Oh.
Make sure you curve your lines around because otherwise it's not just a line that goes off. You need to think about a cubic on its side. And domain and range are easy peasy for this one, yes? Because they are not restricted. If it had an exponent instead of a root, what would that exponent be? 1/3. I could write this as 2 times x minus 4 to the 1/3, and that is exactly the same thing. Okay, don't let that throw you. All right.